Hi there, this is Penelope. This is the second in a series of short videos on force for the Level 4 Foundation course here at Welltech. So friction is what we're going to look at first, and friction is the force that's produced when two surfaces, for example a shoe and the floor, come into contact and kind of grip together without slipping past. That's what stops you falling over. Or when a surface slides over another, like if you're sandpapering, if you're rubbing sandpaper on wood. Friction forces act in many situations, and they always oppose the relative motion of the two surfaces that are being rubbed together. Air resistance, for example, is the friction that's caused when an object moves through the air. Excuse me. You've got to allow for friction when it is involved in a situation. Usually, the friction subtracted from the applied force to give a resultant force. Now, let's have a look at the example here. We've got the thrust from an outboard motor. That's 1,000 newtons. And let's say it's got a mass of 500 kilos. And the friction opposing the boat through the water is, well, maybe you can't see that, 200 newtons. So that the resultant force is 1,000 minus 200, that's 800 newtons. So that's the resultant of the thrust of the motor. Now the question is, what is the boat's acceleration? So the resultant force is going to be, well, we've just worked that out. That's the 1,000 minus 200. And it's going forward because the boat's still going forward. So using that formula that we've seen before, then we can rearrange that to find the acceleration. And now just put in the numbers. So the resultant force is 800, the mass is 500, so the acceleration is 1.6 meters per second squared. Oops. We need to look at a little bit of tension. An example of tension is the pulley force in connecting strings or ropes. The tension tends to pull in both directions along the string or the rope. So let's have a look at the situation here. We've got a stationary mass of 0.5 kilos, and it's hanging on the end of a string from a beam. Now, tension's caused by the string weight, and we could say that that's approximately, say, I don't know, 5 newtons. And then the tension's acting downwards on the beam due to the force weight of the block, but tension also acts upwards on the hanging mass. So you've got a downward and an upward, and the effect of this is that it pulls the string apart. Now, I don't mean it unravels the string, but what I mean is it pulls the string so that it's straight down like that. So you've got one force going up, you've got one tension going up, you've got another one coming down, so one going up and one going down. And the final effect is that the string is hanging straight, otherwise it would be kind of, all folded up on itself like that. Torque, not T-A-L-K, but torque in this sense, T-O-R-Q-U-E, refers to the turning effect about a pivot. And torque, or moment, or leverage, is involved in situations such as when you turn the steering wheel in your car, or when you turn on and off a tap, or when you lift the cap off a bottle, or if you're undoing a bolt. A small force acting at a small distance from a pivot, so we've got the pivot in there, and a direction there, a perpendicular direction to the pivot there, and a torque there. So a small force acting at a small distance produces a small pivot. The same force acting at a longer distance, from there to there, produces a bigger torque, or a larger torque. So a small force acting at a small distance gives a small pivot, whereas the same small force acting at a larger distance is going to give you a large, should say a smaller torque. This will give you a larger torque. Torque is, well, we can work it out from it's the force times the perpendicular difference. Now, the unit for torque is the unit for force, which is newtons, times the unit for distance, which is meters, and we'd abbreviate that as Newton meters. And torque can act anti-clockwise or clockwise. Let's have a look at an example of torque. Now, this is just a diagram to get your attention, as they say. Suppose we've got the lid here of a can or a bottle or something, and you're going to use some sort of bottle opener, and that's 8 centimeters long, and the force that you're imparting is 10 newtons upwards. We need to work out the torque. So from the previous slide, so the force is 10 newtons, and 8 centimeters is, we need it in meters, so it's 0.08 meters, so 0.080, which will give us 0.8 Newton meters, and in this case it's going to go anti-clockwise. The torque will be the same as a force of 40 newtons on a shorter bottle opener. And that's because 40 times, and again convert 2 centimeters, we're going to get the same 0.80 Newton meters. Now we've got, well, still more torque involved, but a couple occurs when we've got two equal and oppositely directed forces. Two equal and oppositely directed forces some distance apart. A couple causes rotation, only causes rotation. So what we've got here is, just imagine this is the top of a tap. I don't know, not very good at drawing. So you're looking down on top of a tap. The torque produced by a couple, or by, in this case, the couple, is it's caused by two equally sized forces in opposite directions. Because you imagine you're putting your hand on the tap top and you're turning it, so the size of the torque is going to be this force. Now this is the pivot point here, so this distance is then half, and it's a circle, so doesn't matter whether it's across or downwards. So it'll be the sum of these two. There's the first one, and then the other force operates in the other direction, which is also half the distance. Now if we perform the maths on that, we get F times D, which is what we already knew, and we've got there